right. Hello, ladies and gentlemen. Welcome back to another online tutorial. We're going to go ahead and warm up with one of our X puzzles where we rewrite quadratic trinomials as a product of two binomials. So go ahead and pause the video, and if you are a student of mine, your most recent set of notes should be able to guide you through this. And for those of you who are not, go ahead and follow along if you have never done this before. So what we are going to do is we're going to start out by creating our X puzzle itself. Okay, I'm just going to start out with an X. We're going to put the value that is right here, okay, in place, or in the top slot right here, -36. Okay, and we're going to place this value right here, not the X, just make it a little bit more narrow. There we go. And this value right here will go on the bottom. Okay, so now, why do we do this? Well, because this quadratic trinomial up here is structured in what we call standard form. Okay, so what we're going to do is, I want you to think of these values here as A, B, and C. So A, B, and C represent the different coefficients in front of the variables of your quadratic trinomial, or the constant at the end. And what we want is, because C is created through multiplication, if you imagine using the foiling method or the box method, the constant that is created at the end is the value that you create through multiplication that doesn't give you any like terms that you combine. Okay, so this value right here is created through multiplication. Okay, and this value down here, okay, in place of B, this is the value that you get after you FOIL that is created by combining your like terms. Okay, created through addition. So the challenge here in this puzzle, or in these problems in general, and this is a shortcut that doesn't work for every quadratic trinomial, but for all the ones that we've done in my class up to this point, this strategy works. We'll get to some where you need to get a little bit more creative, and you need to do a little bit more math to get to the answer, but that's a topic for a different video. So what we need to do is we need to think of two numbers that multiply together to make -36, that add together to make -5. Okay, and while you are pondering that over, I'm going to go ahead and get my binomials that we're going to end up with set up down here. We're going to put our x's in the front, okay, or whatever variable we happen to deal with, and the two numbers that we come up with, one of them will go here in this first binomial, and the other will go over here in the second. If you are still pondering the answer, trying to figure out the two numbers, go ahead and pause the video. Otherwise, I'm going to go right into it. So the two numbers that we are looking for, okay, -9, okay, and +4. Okay, -9 times +4 gives you -36, and -9 plus 4 gives you -5. Now, we're going to put one of these in each binomial down here. The order does not matter. I'm going to go ahead and put the positive 4 right here and the negative 9 right here. So the two binomials that FOIL out or multiply out to give you x squared minus 5x minus 36, x plus 4, and x minus 9. If you'd like to try it yourself, by all means, go ahead and pause the video and go ahead. So again, that was meant to be more of a warm-up. If you would like a full-on tutorial on how to think and approach these X puzzles, my students, we've gone into greater detail about how you know when you'll need different signs and when you'll be able to recognize when the larger of the two numbers needs to be positive or negative. We've gone over that in the past. If you would like for me to create a video on it, just let me know in the comments below. I already have the notes ready. I'll shuffle a few things around and add maybe another example or two to flush out the topic a bit more. But again, just let me know. Now, I teach factoring quadratic trinomials using that shortcut before I go into trying to remove the greatest common factor. I know other algebra teachers do it the other way. That's not how I do it, but you do what works best for you. So we're going to talk about a different way of factoring various polynomials, and we're going to do that by factoring out the greatest common factor. Okay, we're going to write polynomials as the product of a monomial, okay, and then a binomial or a trinomial, or sometimes another monomial, depending on how it goes. So that's what we should be able to do by the time we are done with this video. Okay, so just a couple of examples here. Very basic. We are going to, for the next few examples, whenever we deal with a coefficient, we are going to break it up into its prime factors, okay, by creating the factor trees that we use to find greatest common factor of, just regular old integers, and the same method that we used for finding or simplifying the square roots of numbers that are not perfect squares. So for 15, I need two numbers that multiply together to make 15. Okay, that would be, oops, did not mean to use blue. That would be 3 and 5. And it looks to me like, just like that, we've already factored it down to nothing but prime numbers. Okay, we've all done this before. For some of us, though, it may have been a while. So let's do another one. Okay, 32. I need two numbers that multiply together to make 32. For me, what comes to mind immediately, the numbers 4 and 8. Okay. Neither of these are prime numbers, so we will factor them a bit further. So we'll factor that into 2 and 2. 8, we will factor out into 2, 4. Okay. 2 is a prime number, so I'm going to go ahead and circle these so we don't lose track. 4 is not a prime number, so we're going to go ahead and keep going. And you're going to see that we end up with a boatload of 2s right here. Okay, and there we go. 2 times 2 times 2 times 2. 2 times 2 times 2 times 2 times 2 gives you 32. But sometimes you'll end up with a number like 17, where it is already it's already a prime factor. Okay, so sometimes you are not able to do this if your coefficient is already a prime number to start with. Okay, and we can tell that 17 is a prime number because the only two numbers that multiply to make 17 are 17 and 1. Now, when it comes to factoring out variables, it's basically taking the variable in exponential notation and rewriting it in expanded notation. Okay, so x to the power of 4 would be x times x times x times x. And there you go. You have factored x to the power of 4 all the way down to its prime factors. Okay? The same thing will be true for y to the power of 2. You're basically just, like I said, going to rewrite it using expanded notation. Y to the power of 2 would be y times y. And there you go. That's the prime factorization. And just like with 17, if you just have a z or a variable to the power of 1, it is already written as a prime factor, so there's nothing that you can do with it. Okay, let me move this over here, and let me blow this up a little bit. Okay, so for my students, okay, I'm going to let you know in advance that this will likely be a bit strange at first. But I have plenty of examples planned, and again, let me know in the comments if you need more, if I haven't done enough. But I think you all will get it by the time we are finished here. So what we are going to try and do is we're going to follow these list of steps right here. Okay, so list the prime factors of each term, identify all the factors that are common to all the terms. Okay, and we'll go down the list, but we'll start with just those two. Okay, so we are going to figure out what can we factor out of both these individual terms that make up this binomial that we are dealing with right now. And we're going to deal with each term separately and each piece of each term separately. Okay, so what I'm going to do is I'm going to ungroup this. It will let me. It will not. Whoa. Okay, let's not mess with it. Otherwise it might get angry and crash. Okay, so let's start with this term right here. I'm going to box both of these. And what we're going to do is we are going to start with the coefficient of each term. So we will start with the 16. Okay, and we will factor this all the way down to prime numbers. So to me, when I see the number 16, the two numbers that jump out to me that multiply to make 16 are 4 and 4. Okay, and I know that 4 definitely not a prime number. Let's factor all of these down to a bunch of 2's again. Okay. And now what we're going to do is we're going to do the same thing with our coefficient in our second term. Okay. 4 times 2. And factor this down to 2 times 2. Okay. So at this point, we have everything factored down to prime numbers, and what we need to keep in mind when we factor is we need to factor equally from both of these numbers. Okay? And basically what we're going to do is we're going to take all of the factors that are common in these terms. Okay, and we need to we need to take them equally from both coefficients. Okay, so I look over here, and I see that we have a 2. We have a 2 right here. So both of these terms have a 2 to give away. I see they have a second 2 that we could borrow from them. And we have a third 2 that we could borrow from them. Now, the 16 here has this fourth 2, and as much as I would like to have a fourth 2, this over here, the 8, does not have a fourth 2 for us to factor out. And remember, we need to take equally from both of them. Okay, so we are only able to take out 3 2s. Okay, so 2 times 2 times 2. Okay, and 2 times 2 is 4, times 2 is 8. Okay, and now we're going to do what we did here with the coefficients. We are going to do with the variables now. Let me go ahead and do this. Draw a line across, and we'll start with the x to the power of 3, and we're going to write that as a list of prime factors. So that'll be x times x times x. Okay, and if you'd like, you can put circles around them, just like we did with the 2's. And over here, we have x to the power of 2. X to the power of 2, written as prime factors, would be x times x. Okay, and what we'll do is we will circle them just like we did our numbers. And again, now we need to figure out what they have in common and take equally from both of them. So I look over here and I say, hey, we've got an x that we could borrow from both of them. And it looks like we have a second x that we can borrow from them. This term here has run out of x's to give away, so we can't borrow anymore. Okay, we could take a third one from this one, but that would kind of break the rules because this x to the power of 2 does not have a third variable to give away. Okay, so it looks like we're just going to be borrowing 2x's. X times x. And x times x is x squared. Okay? And so now we've listed all the common factors, and we're going to multiply them together to find the greatest common factor. So 8 times x squared is going to be 8x squared. So this is what we are going to factor out of our binomial. And this is where things might get a little bit strange, but that's okay. That's why we're doing multiple examples. Here's how it's going to work. We are going to divide each term by the greatest common factor that we just calculated. And for this, we're going to have to remember a couple of things. Okay, first, just standard old division for dividing the coefficients, and then for dividing the variables. Okay, remember, when you divide two terms that have the exact same base, you subtract the exponents. Okay? So for the 16x to the power of 3, let's divide the coefficients. So 16 divided by 8 gives us 2. then x to the power of 3 divided by x to the power of 2. I'll write that over here. X to the power 3 divided by x to the power of 2. Okay, you keep the base and you subtract the exponents. So that would give us 2x to the power of 1, or just 2x. Okay, and then we bring down the subtraction symbol, that's right here. And now, what's 8x to the power of 2 divided by 8x to the power of 2? Well, other than the number 0, anything divided by itself is 1. Okay, 8 divided by 8 is 1. X to the power of 2 divided by x to the power of 2 is 1. Okay? So this is what we end up with after we have factored out our greatest common factor. And now the last step is just to write our greatest common factor on the outside. 8x squared. And there we go. We've done it. This is our final answer. Okay, and if you use the distributive property, okay, you multiply everything inside the parentheses by the term on the outside, you'll end up with 16x to the power of 3 minus 8x to the power of 2 again. I know it's a bit strange. Okay, it's a lot of rules to keep in mind, but don't panic. We're going to do a couple more. Okay. So let's start with listing the prime factors of each term. And once again, we're going to look at these one piece at a time. One piece at a time. And we're going to start with the coefficients. Okay, so I'll put 22 right here. Okay, and our coefficient over here is 33. And let's factor these down to prime numbers. Okay, so 22, 2 times 11. And both of these are prime numbers. So I'm going to go ahead and circle them. And we're done factoring 22. Let's do the same thing with 33. Okay. So that would be 3 times 11. And again, just like that, we have factored these down to prime numbers. Okay? And now what we need to do is we need to take a look at all the factors that they have in common. Okay, so I look over here and I see that we've got an 11 in both terms, and that's about it. Okay, so in terms of our coefficients, the greatest factor, or the greatest number that we can factor out, is going to be 11. Okay, what happens to the 2 and the 3? Well, don't worry about that. It's okay. We'll get there. And draw our line across, and we're going to do the same thing with the variables. Okay, so z to the power of 6. And I am writing with the mouse, so if everything isn't perfectly neat, doing the best I can. Z power of 5. And we're going to write it in expanded notation, so that would be z times z times z times z times z z. 1, 2, 3, 4, 5, 6. Okay, I'm going to circle them. Okay, 1, 2, 3, 4, 5, 6. Just had to make sure. Okay, and same thing over here with the z to the power of 5. In expanded notation, that would be z times z times z times z times z. 1, 2, 3, 4, 5. Circle them. Okay, and now we want to take as many z's away as possible while being fair to both terms. Okay, and that will tell us how many we're allowed to factor out. Okay, so I see that we have 1 here that each one is able to give. We have a second z that can be factored out. A third z can be factored out. A fourth z that can be factored out. And a fifth z that can be factored out. And I believe that's all we can remove, okay, because this term over here has run out of z's to donate to our cause. So 1, 2, 3, 4, 5. So we are going to be able to factor out z to the power of 5, and we will multiply them together in order to find the greatest common factor. So 11 times z to the power of 5 is going to be 11 z to the power of 5. Okay, so that's the greatest common factor. I'm going to draw another line across. Okay, and now we are going to go back up here, and we are going to divide each term by the greatest common factor. Okay, and we'll start with the first term in our binomial here, which is boxed in blue. Okay, let's divide the coefficients first. Okay, so 22 divided by 11 is going to give us 2. Okay, and z to the power of 6, z to the power of 6, divided by z to the power of 5, z to the power of 5 is going to give us z to the power of 1, or just z. Then we bring down our subtraction sign. If it were a plus sign, we would bring it down all the same. And now we're going to do the exact same thing, okay? So 33 divided by 11, that would give us 3. And now z to the power of 5 divided by z to the power of 5. Okay, we subtract the exponents, and that gives us z to the power of 0. Okay, and for my students, if you look at your properties of exponents foldable, there is a wedge on your graphic organizer dedicated to the zero product property, and that states that anything to the power of 0 is 1. Okay? Now remember, because these values right here are right next to each other with no sign in between, that means they are being multiplied. Okay? So the 3 and the 1 that we would get from factoring out the z to the power of 5, those would be multiplied together as well. Okay, so and then 3 times 1 would just give us 3, right? Okay, so that is everything that is left over. Okay, that's everything that's left over when we factor out our greatest common factor. Okay, so we have divided each term by the greatest common factor, and now the last step is to just write our final answer in factored form. So this is what is left over, and now we just put the greatest common factor on the outside. And there we go. I like to use the highlighting tool. Just bear with me. There we go. There is our final answer. And once again, if you would like to double check to make sure that the answer is correct, if you multiply, okay, or use the distributive property, multiply everything inside the parentheses by the term by this monomial that we have on the outside, we will end up with 22z to the power of 6 minus 33z to the power of 5. Okay, and that is example 2. Hopefully, it's making a little bit more sense. We are going to increase the difficulty just a little bit here on this last one, because this time we are dealing with a trinomial. Okay, and basically everything we've done in the last two examples is going to carry over to this one, except instead of having two terms that we'll need to write as prime factors, we have 3 this time. Okay, so I'm going to box these all the same. Okay, and again, because it's a trinomial, we have 3 terms that we need to write as prime factors. Okay, so we are going to start with the coefficients as usual. So we'll start with the blue coefficient, or the coefficient in the blue box. So that's 5, and 5 is a prime number, so there's nothing to be factored from it. Just a moment. The cat has decided to double check and make sure that everything is going according to plan. So let's move on to the next coefficient. Okay, so we'll go to the one in the red box. Okay, which is 20. Two numbers that multiply to make 20. For me, what jumps out immediately is 4 times 5. If you decided to go with 2 and 10, that would be okay. You'll end up with the same list of prime numbers in the end, as long as you divide properly and multiply properly. 5 is a prime number, so I've circled it. 4 is not a prime number, so let's factor it a bit further. Okay, so that gives us times 2. Cat, go away, please. And last but not least, we'll go to the 15 over here. Okay, and let's factor this guy down. So 15, that would be 3 times 5 gives us 15. Ugh, did not like that. Arguably worse, but you know what? We're going to go with it. Okay, so now let's look at each list of prime factors, and we need to pick out what they have in common. Okay, and while we figure out what that is, let's approach this in a slightly different way. Let's actually use, what I have these sections here for in our foldable. And let's move on to the variables. Okay, so the blue, we have x to the power of 3. Written in expanded notation, that would be x times x times x. Okay, and we circle them. Okay, x to the power of 2. Okay, for our second term, x to the power of 2. Okay, in expanded notation, that would be x times x. And there is no variable over here. Okay, so there is no x. No x's to be given away. So 5x to the power of 3, if we write it as nothing but prime factors, okay, that's going to be 5 times an x times another x times another x. Okay, all I did was I wrote everything that was circled over here on this line. 20x to the power of 2, that would be what's here in red. So everything that we have boxed, we're just going to rewrite. So 5 times 2 times 2, right? That's all of our numbers. And then we go to our variables. That'd be times x times x. Okay, and then in green here, our third term, 3 times 5. And there we go. We've listed all the prime factors, and now we need to identify the common factors. Okay, so I look in each list, and I see that we have a 5 that we can borrow, and that's it. There is nothing else that we can factor out of this trinomial. Okay, because any common terms or any common factors need to be present in all three lists. Okay, so you might be thinking, okay, well, we could borrow some x's from these two terms right here. Well, we can't, because we would have to borrow 2 x's from our third term down here, and the third term does not have any x's to give. Okay? So our greatest common factor for this problem, seems a bit anticlimactic, is just 5. The greatest thing that we can factor out of this trinomial. Okay? So now let's divide each term by the greatest common factor. Okay? 5 divided by 5 would just be 1. It would just be 1. And then because we didn't do anything with the variable, it's going to be x to the power of 3 plus 20 divided by 5, just be 4. And again, nothing with the variables has changed. We did not factor out any x's, so nothing changes about the variable. Okay, and then 15 divided by 5 would give us 3. And I just brought down the plus sign and the minus sign and put them in the exact same spot. Write your final answer in factored form. I'm going to use pink. Okay, so we put what's left over after we factored out the 5 on the inside of the parentheses, and then the 5 itself moves to the outside. And there we go. We have factored out the 5, and that's about all we can do with this particular trinomial. So that is example number 3. What I'd like to do now is I'd like to just quickly go through an example of a problem on Khan, and I want to show you the instructions real quick. Scoot this over here. For those of you who are not in my class, Khan Academy at every problem, or for every problem, has a step-by-step set of instructions that show you how to go through the problem, and it shows you what the final answer is at the end, which is nice. But sometimes I feel the instructions are not communicated in the clearest way possible. So I'd like to do one more example with everyone, but I'm going to go ahead and block this. Okay, and we'll solve a problem together, and we'll double check the answer to make sure that everything checks out. Okay, so factor the polynomial by its greatest common monomial factor. Okay, so we are going to start by putting a box around everything. Okay, nothing has changed. And we're going to start with the coefficients first. So a 20, 15, and let's scoot it over a little bit. And 40. So 20 factored down, it would be 4 times 5. 5 is a prime number, so I'm going to circle it. 4 is not a prime number, so we factor it down to 2 and 2. And that's it. Okay, we go here, 15. That would be 3 times 5. Both of these are prime numbers. And for 40, that's going to be 8 times 5. You can use 4 times 10 if you'd like. You'll get the same list of prime factors at the end. And 2 is a prime number, so I'm going to circle it. And over here, 2 times 2. There we go. So let's find out what they have in common. Well, let's look at both lists. Remember, we have to take equally, okay, from all three. So it's got to be something that you see in all three lists. So I see that each list has a 5. Okay, I see a couple of 2's here, a couple of 2's here, but there's no 2's here in the list for 15. So we can't factor out any 2's. There's a 3 here, but there's not a 3 in either of the other lists. So it looks like for our coefficients, the greatest factor is going to be 5. Hold on, let's do this. Let's put it right here. Okay, and we're going to do the same thing now, but with the variables. Okay, so y to the power of 6. So y to the power of 6. I'm going to run out of room pretty quickly here, so I'm going to try and write it in expanded notation without taking up a whole lot of space. 1, 2, 3, 4, 5, and one more. And we're going to circle them. 1, 2, 3, 4, 5, 6. Okay, y to the power of 4. Y to the power of 4 would give us y times y times y times y. Circle them. And all we did was we wrote it, instead of writing it in using exponential notation, we wrote it in expanded notation. Okay, and last but not least, we have y to the power of 2. I'm going to break the format a little bit here. I do apologize, but space is limited. I don't want to make things too small, just in case you're watching on a cell phone. I don't know. Sometimes it could be hard to see. There we go. We have all of our variables listed as prime factors. And now we're going to borrow what we can from each of them. So I see that they have 1y to give away. And they have a second y to give away. And that's it. Okay, these two do have more y's to give away, but we have to treat all three of them equally, and we have to take from all three of them equally. Okay, so that's going to give us y times y. So that'll be times y times y. Okay, and y times y gives us y squared, and then 5 times y squared is, well, just 5y squared. 5y squared. Okay, so our greatest common factor is equal to 5y squared. Okay, and we are almost done at this point. Now we just need to divide each of these terms individually by our greatest common factor. I'm going to go ahead and get rid of this just to clear up some space on the screen. Okay, and we'll start with the coefficients. So 20 divided by 5 gives us 4. Y to the power of 6 divided by y to the power of 2 gives us, okay, we subtract the exponents, and we get y to the power of 4. Okay, I'm going to bring the subtraction down from the problem. Now we'll move on to the red term. So 15 divided by 5 is 3. Okay, and then y to the power 4 divided by y to the power of 2 gives us y to the power of 4 minus 2, which is 2. Okay, I'm going to bring down the plus sign. And let's do the same thing. We switch to green. So 40 divided by 5 gives us 8. And then y to the power of 2, divided by y to the power of 2 gives us y to the power of 0. Anything to the power of 0, except for 0, is 1. Okay? And remember, this 1 that we factored out and the 8, we would multiply those together, but anything times 1 is itself. So this is what we are left with. Can I move all of this? No, it's not going to let me. So this is what we are left with when we are done factoring everything out. Okay, so I'm going to go ahead and type that into our answer. So 4y to the power of 4. It's kind of dark in the room, so bear with me. 4y to the power of 4 minus 3y to the power of 2 plus 8. Okay, and we close the parentheses. That's what we are left with after we are done factoring everything out. And now the last thing we have to do is just put our greatest common factor on the outside. So 5y to the power of 2. And there we go. We got it correct. The square or rectangle that I'm using to block the instructions is blocking our little hooray. And again, I wanted to go over a fourth example, not only because, it's good to have as many examples as possible, but I think Khan's instructions um, could be a little bit more specific on how to approach the problem, but I mean, if you look at the steps and they make sense to you, then excellent. But if you are someone who, looks at this and you're like, oh, that looks different, I don't know what he's doing, then just follow the examples that we've done here in this video. So, I'm going to assign this to my students tomorrow. So once you're done watching the video, go ahead and give the assignment a shot. If you run into any trouble, please leave your any questions that you have in the comment section below, or you can post them in Google Classroom, or you can email them to me directly. I know this one was a bit of a long one, a bit of a strange topic, and it takes some getting used to, so thank you for making it to the end of the video if you've stuck with me all this way, and I'll be back in the near future. Take care, you guys.